So this time the next visualization library that we will start to learning, this is C1. After the matplotlib, the major time we will work on this data set, that's the C1 library. And you will ask that what is the advantage of using C1 and why we will use C1 when the matplotlib also provide the same kind of concept and parameters when we start to plotting data and all. One advantage is C1 provide a more types of better visualization than matplotlib. Why? Because you will when you will try to plot the data in the matplotlib, you will see some overlapping of your data. Okay, some plot the data, show the visualization, maybe some overlapping of your graph, maybe the data point will there. So for this that means the default adjustment of this parametric view. Okay, this automatically done in C1. So the automatic adjustment that if we did not have to provide anything, we just let C1 to decide whatever parameter they will start to use, what parameter they will start to optimize. Okay. That part C1 will do much better than matplotlib. Then what's the point of using matplotlib over C1? Yes, because matplotlib provide the basic adjustment like creating the empty plot like subplot. Okay, you already know that creating the subplot and all. Those the basic than creating plot. Those kind of adjustment are much better in our matplotlib part. And then after plotting the data visualization, the overlapping of the data, those kind of mistakes avoided in most general in a C1 part. These two visualization tool are in general we use, but for a visualization there is no one. There are other like plotly and uh, what is called plotly and all. Not really. So there are another 5 and 6 types of library that people sometimes use. It's depends on our requirement. Okay. The one more advantage of using C1 data is if for our practicing purpose, okay, for any kind of practice, either we will do some data pre-processing, data visualization, like basic pandas manipulation, basic numpy work. Like if you want to practice data and we need a data set, then Seaborn already provide a mode of 8 or 10 types of data. If we search like uh, Seaborn data sets, just go to the documentation. The better if we see the documentation rather than other one. And simple we need to write Seaborn. Sometimes we use aliases, SNS and all. So we can use the aliases and can just load the data in the C1.load data set. Then there is some data. You just go to the documentation, get the data set name. These are actual repository. Yes. This is 9 types of most general data that C1 are provided. Okay, like IDs data set, okay, your flights data set, then gender data sets. Where are the data sets? Yes, those are the data set, anagrams, attention, brain network, car crashes. Those all types of data sets are providing is the C1, and in there those are the before process data. So if you want to do like some kind of practice, you can do using practice the C1 data set, like basic data manipulation, encoding, and some your scaling, missing value treatment, replacing some values. Okay, all those kind of data say practice you can work using this, all those data set. People mostly use Titanic tips, IDs, okay, flights. So those things people in general use, but you can just load the dataset simple SNS dot loads, what is this called? I'll see you those things. Then load those data, get using. Those are the repository of all those CSV file. You can see some new are added. You can see this. This is a new data set that are added that I never work on the taxi data set, because those two you can see is the contributor people. Those people are completely working, like people work in a different industry. Similarly, people also work for Python, like from some Python organization. Those organizations also have some employees, so who can develop new libraries, who can develop new, or maybe debug some errors. Okay, so those people till days try to develop something new and providing. So you can also see these people's. Okay, these two you can see. Yeah, one thing you can see that these people already own that one. This Seaborn library, he owns that one because he worked for that. So he can means allowed to do each and everything. So you can see that's maximum. Here are the links. If you want to see something about the data, then those links you can go through. This is the repository of it. Then we import the data set and we will do all kinds of plots. Either it's a distribution plot, or it's some kind of joint plots, or it's a pair plot, or a kernel density estimator plot, okay, KD plot, or it's a RAT plot. We'll see. So first we'll import that simple. Then as a, if you want to take that plot within our same Jupyter file, that's why we write matplotlib inline, nothing else. So the plot will be stays within here. Then here we wrote a simple load that tips data set. It is nothing but the total bill, the which people are giving the tips amount, which time they are providing, which day they are going, which time they are taking, either it's dinner or lunch. Okay, how much amount of people are going within it. So this is kind of data set information we have. Okay, now we try to do the first is the distribution plot. Distribution plot is the data distribution, that maybe we check the frequency of the data. Okay, okay, but maybe some standard deviation of the data we'll see by our eyes. Okay, so for our load data set we can simply write tips load data set, then our data set name, because the data set already provided, and the name should be matched within this one, or maybe within this one. Okay, anagrams, then should be the exact spelling should be this. Okay, so for a simplicity, the developer already know, that's why each and everything will be written as a lowercase. Sometimes they provided the space with an underscore, because there's a standard way that people will know. Okay, if we maybe just get some errors, then just Google it. You will see the which, for which purpose you will receiving that error, and you will just work through. You will solve it out. Okay, in general, we will not get any error. This is our data set. Then this is our data set. Next time we will try to plot and distribution plot. The code is so simple. We just write like cborn.distplot, cborn.distplot in bracket. There are tons of parameters will be there. You, all of you, you do not have to memorize anything. Just if you like want to search something like, okay, maybe I want to see what kind of features are providing. Just search cborn.distplot, and you simply go to the API and the documentation in your Seaborn, that API, the document distplot, and we'll see the all the parameters are providing. You do not have to memorize that which parameter are doing what things, what is the purpose of it, because all of the things are written here. They updated that documentation. Otherwise, some like cat plot or rag plot, all of the parameters are written here. What is the purpose? Like data frame, XY other variable. Okay, estimator are nothing but the vector and the scalar estimator. We'll do when we'll run the stat part. Okay, then in units, you don't have to memorize anything. You maybe most of the time you do not need maximum parameter rather than just data and the color and all. Okay, this is this one. If we already, oh, what happened was before. the disk plot here, each and every parameter descriptions are there, but maybe as people will be requested, so this part is changed. I'm seeing right now, I'm seeing previously it was not there. It was just simple written each and everything. So histogram and disk plot. Yes, yes, this part was there before. Now the page is changed. Okay, and he gave one guide plot, and you can see where each and everything are written there. Okay, don't worry. So go to the disk plot, and you will see those are the parameters. Okay, data, variable, hue are nothing but we'll check that how much, if you guys ever work with any photo editing, or maybe if you do some photo editing on your mobile phone, you will know what is the hue color. It is nothing but some variable to determine the how much hue you want to put on. Either it's a low maximum amount or the minimum amount. That's all. Just kind of transparency of your color. Then row, column, see maybe some vector colors, kind, rug. It's try to put some marginal ticks in the rug. Okay, some logarithm scale, some legend if you want to write some heading or some mention some words inside your visualization, then you can write some legend. Okay, in general, you could provide some boolean values. So those are the many parameters are there. Okay, so come back to here. Here nothing but we'll plot in the distribution plot of inside our data set from the only column of total bill. Okay, we plotted the data. There are some warnings come because you will see the warning will be the visible deprecation warning. Okay, using a non-integer number instead of an integer will result in error in future. Okay, why it gives a warning? Sometimes, most of the time, when you build one model, okay, so in the next time the data may be changed, but the model didn't. The model code are fixed. So maybe if you have some non-integer data, then this format may not be working. That's why the people trying to give this developer trying to give for warning. Okay. You just have to work yourself, like some this function you can work with yourself, or just Google it. You will find the solution. Okay, just you will need that. But for the most of them, we don't need it. We can just simply ignore because sometimes you will see maximum time in Kaggle or in other module, people will use ignore warning one module, one library. So those are the people will ignore that set. Maybe it will not changing in the future. We are just doing some basic analysis, so it will not make any impact. Okay. So this is the distribution plot. Distribution plot, and by default, C1 provided one our what is called this. If you have idea of PD, probability density function, PDF, probability density function. So this is simply nothing but our probability density function. And it automatically tried to plot one density function. And these bars are nothing but representation of data, because it's an bill amount. Yes, total bill. Total bill is the amount. So try to automatically divide into some segments, and within the segments, if the data is come here, then they just stack within each other. So the maximum value we can see that from the visualization, maybe if this point is 10 and this point is 20, then in between there may be two parts. So uh, so total are 4 parts of difference. So 10.25 means 12.5, 15, 17.5 and 20. Okay, so 4 parts. So we can see maximum value, it will be there in between 15 to 17. Okay, by our naked eye we can come into one statement that people will be expending the amount of 10 to $20. The maximum people will be spending that amount. Okay, or maybe you can took some statistical approach to validate your response, like some 95% probabilistic value of this expenditure is will expanding within the 10 and 20. Okay, but you can see this function is not a normal distribution. Normal distribution, you will know that for a normal distribution, the data will be evenly separated most of the time. So there is some skewed in this data set. Okay, some right skewed of our data set, maybe a little bit, but it's something like right skewed you can see. So this is some kind of judgment you can do within by seeing that, or maybe just seeing this from the data set. And next you will work on like how we can change that right skewed data to the standard normal distribution. Those are the approaches. Okay, so this is simply nothing but we get the distribution plot. The maximum distribution of the data will be, we can see the between the 10 and $20. Okay. The next, this kernel density estimator or the function, this probability function, if we don't want that, then we automatically read that KD is equal to false. So it will not, we'll just simply watch the distribution. And sometimes this horizontal stack will call beans. So we will mention that beans is 30 or how many beans you want to divide. So maybe it will not try to overlap. So if this is small data, then it will not providing, but if it will be a large chunk of data, then it cannot beans means divide the beans into the multiple amount. So it will throw you the problems. Okay, so run the model. So just let it Sibo to do each and everything. Okay, they adjust the parameter and all. So this is how we got the distribution plot. We get the frequency of the distribution and we just stack each other. Okay. Now next time is called this joint plot. Okay. Joint plot is nothing but here we'll see three types of graph. One is this is kind of, you will see the basic scatter plot of your total bill versus tip, because we mentioned that value x-axis will be total bill and y-axis will be tip and data will be tips. Okay, so just nothing but plotted the scatter plot, and from this, because this is a joint plot, so it will also do some univariate analysis and the bivariate analysis. In the middle part, we will see the bivariate analysis. Bivariate analysis is nothing but when we will do the analysis using the two variable, and univariate is nothing but we will do the analysis in one variable. So univariate analysis you cannot.
Sir,
Yes.
বুঝি স্যার একটা মানে কথা ছিল যে স্যার আপনি ডিস্ট প্লটটা যে ইউজ করলেন, মানে যেটা ইউজ করলেন, তো ওটার স্যার আমি যদি স্যার ধরুন মানে সেমই হবে, এই যে কার্ভটা হয়েছে ডিস্ট প্লট, দেখুন ওটা এক সেকেন্ড, ওটা তো যদি আমি লিখি যে সানস ডট হিস্ট প্লট দেন দিয়ে মানে ভেতরে দিই কেডি ট্রু, তো দেন এইটাই তো আসবে মনে হয় নাকি সেম টাইপেরই।
this function, this pdf function will come.
এটা হচ্ছে হিস্ট আর কেডি মার্চ নাকি?
হ্যাঁ, এটা হচ্ছে তোমার যে মানে ডিস্ট্রিবিউশন যে গ্রাফটা যেটা প্লট করেছি সেটার মানে প্রবাবিলিটি ফাংশনটা আমরা ট্রু করছি বলে দেখাচ্ছে, আর কিছুই না।
ওকে ওকে ওকে,
ইটস নট নেসেসারি বিকজ দেখো, in simple language, the more people will try to ask you the same things, like why you put this one, why, or maybe sometimes say why you didn't put the probability density as a function. Then just you have to prepare with your answer, nothing else. Okay, and it's just up to you that which gets you the more secure or maybe the more analytical approaches. Okay, that part you like to always try to visualize it. Okay. Because these things we can say, I mean, in that part I know this is nothing but right skewed. Okay, if you know the statistical distribution basic, then in general for our shape means the frequency means the distribution, the data distribution, the frequency of a distribution, based on it we always get three types of shape. Okay, one is left skewed, one is right skewed, and one is normal, standard normal distribution, symmetry. So this is, you can see that this one is the left skewed. Okay, and this is, you can see the right skewed. So
Right.
from that point of view, you can, you already can understand that the data will be mostly accumulated here rather than here. If I give it another color, then this is an important its concept, means statistical concept. So data will be maximally accumulated here because we do the frequency distribution. So this is not, we cannot give the dot laser. We have to display the beans. Okay, we have to display the beans here. Maybe this one is the highest. Okay, maybe this one is this one. Okay, one, and maybe some small bean here. Okay, some, maybe some one bean here and one bean here. So you can see this is a frequency distribution. But if this is one of the frequency distribution, then this is the left skewed. But the good or is the data should be in the normal distribution. That's always we always try to work on. So what will happen when the data will be this normal distribution? Then data is evenly separated. Okay, so the frequency will be evenly separated. So what will happen if data is that much separated? Then your accuracy will be better. That's why we try to always do the standard normal distribution. Okay, maybe the data, the optimized result from your model you will come is always lower than your standard normal distribution, because the data has some discrepancy. Similarly, this one, the right skewed, maybe some higher value are here. Okay, and some frequency distributions are here within that range. Okay, X is nothing but it does the range. So always your standard normal distribution or normal distribution always does the better job when distribution the data compared to a left skewed or a right skewed. Okay, so that's why you can see here, this is nothing but the left skewed right skewed of our data. So always on our practical work, the practical task will be, if you see like this is the data set you receive, maybe after all the data pre-processing you have done, you did the data, completed pre-processing, the treatment and all, then you have this data, you try to, okay, now I try to do the EDA part. Okay, then from that EDA part you will see, okay, this is an important column, but the data is a right skew. So now I had to try, if right skew data I will plot, then the model value will be definitely lesser. So I will try to scale it. I will try to convert this right skew data to some standard normal distribution. Okay, standard normal distribution, there is some formula. Okay, like some mean minus current mean divided by standard deviation, x minus mu divided by x minus mean divided by standard normal distribution, standard deviation. That's how we can create the z value, and from that point we can create that. This is simple. It's so simple that when I try to give you the practical knowledge, you will understand. But for now, this for our basic concept, we cannot, you can work on, if you try, you can work on right skewed data, you can work on left skewed data, you can work on, but always your model will be not optimized enough. So always you have to try to convert it into the SDL part, and that part will come into an ADA. Okay, this is the importance of DA, where you do, and for one data set, because you try to analysis using the one data set, because there is nothing other data is plotted here. Mostly we do the frequency distribution. This is technique. This is called your univariate analysis, nothing else. Okay. This is nothing but univariate analysis. Those of you may heard those big terms, they're nothing. This is just simple. Clear? there are some formulas, okay, for your skewed data, but as I told you, you do not have to memorize all the formulas, because the formulas, if I remember, there was nothing but a single distribution. If I get one data point from here, one data point minus of entire mean of your data set divided by the cubic root of this data point minus the entire the mean of the entire data set, the cubic root of this square. This is, I guess, the right formula. Skewed data set formulas. As well as skewness is the 3 times of mean minus median divided by standard deviation. Okay. So this line, when we tried, because this is a concept now, this is the time people write using like for one single data set, you can write in one for our entire data set, it comes up to the n. Okay, so that part people will write like 1 by n1 or maybe some n, and then summation of your n minus 1, not that n minus 1, because n minus 1 to this should be some 1 minus some value, say I or j to n. Okay, this is the end part, and then your data point of x minus x mean, is it, or x is your simple that point only if we consider that point, and this is q. Okay, mean minus median, because we are considering one point, and then for our entire data set, this is nothing but your cubic root of the exact same thing, this exact same thing, 1 minus n establish I minus j to n x I minus x square. This is the mathematical formula people derive. If I am not wrong, okay, because I could not remember much, but this is something like cubic root of and the square, cubic root of square. Okay, this is the skewness how people try to remember. And now, like I told you, that how it will take 6 months. You'll ask, this is the time that how it, because when you try to analyze or learn that how this formula derived from the each basics point, that time you will definitely take some times to like prove that algorithm. Okay, so what we will do, we did not need each and everything, we just simply has that formula, import that formula from your scalar, okay, and just apply it to convert it into our standard normal distribution. Or maybe for the standard normal distribution, nothing but we just divide it by the means, and we just subtract the means and divide it by the standard deviation. Okay, clear, I guess. Okay, so this is the distribution plot. Similarly, the joint plot, where and the simpler this one part is your univariate analysis, and this is because the two variable we will do, this is called the bivariate analysis. And now if we start like deep digging, like okay, first we learn to understand, we get the one data point, we only do what we only do univariate analysis, nothing else. We cannot do model prediction, all blah blah blah. If for a simple, if nothing else are there, for a simple, if the like the world start, okay, like world start, the first generation came, the second generation came, like so the same thing, the first thing come is your one data analysis. This is the univariate analysis. For univariate analysis, do you need any machine learning model? I believe no. Do you need any other techniques? No, we can just simply do like basic statistical approach, like frequency approach and distribution approach and nothing else like that, PDF and all, and we can simply do like univariate analysis. One step ahead, we can get two variable, and now we can start doing the bivariate analysis. How we can check the correlation of the data. This comes by analysis. More further, we can do the regression. More further, we can do the classification. Okay. More further, we can do the clustering. This is how techniques came one by one, how develop things. Okay. Now I have the one data analysis, I have the two data analysis. Now if the data will multiple, now you'll start to think, okay, now I cannot do more than data within by using the pen and paper. Now definitely I need some boosted brain, some advanced techniques, advanced systems to solve those things for me. So we invented different kind of libraries for our system and our computer to do all those calculation for ourselves, for our code, and without any headache we can get that final result. So that's how the new the technique are came. Okay, so this is the joint plot result. There one there's some like this is scatter plot, that's why it's read as scatter plot, because if you're in the hexagram, hex means nothing but the maximum gradient one. You can see the kind of deep bluish or blackish figure are the most accumulated data points, and the come goes to the more light faded data points are the least amount of EMP. Sometimes you can do is like do one more notation where you can give that frequency, like from that color code you can give that frequency. You can also do like that, but people will understand. That's why sometimes we just ignore those parts. Okay, this is joint plot. Joint plots we do, but most of the time we do not have to do the joint plot because there is one good option. We'll see that with the major of the time we'll try to apply it. Okay, here nothing else, the same joint plot, but what we will do, we try to plot one regression line, because it's simple linear regression, the two data points are there. So just kind is reg means regression line, so the maximum accumulated one straight line will be written here. And that projection, you can see the projection of this light is gray are nothing but the in future the data point, the tendency of the data point can be less within that range. Okay, that's the simple is the projected. But you can see, if I ask you, for those who has a basic understanding of like fitting data and all, is it okay for a means this analysis is okay for linear regression? Yes or no? Guess, you can guess whatever comes into your mind. If this is the data point and you were try to do some analysis, then I'm asking that is it okay to do simple linear regression? Don't want to try. So if we just check here, means in your eyes, you can ask one thing like, is that straight line is enough to fit the data perfectly?
No, sir.
Why?
There are so many points.
Hmm.
So,
The you can tell the more approachable is because the data, the maximum data points, maybe some other data points, the distance between the fitted lines, okay, the distance between the fitted line to that point will be much bigger. Our aim is, that's how regression came, the regression approach came. Our aim is to fit what that term is called the best fitted line. Why? Because the best fitted line will have the least amount or the minimum amount of distance from the data point to the line itself. That's how it's come that the best fitted line. That's how we call this regression. Okay, Soumitra was try to learn the regression when it will start. This is the main approach. This is the main concept of regression. We want to fit that best fitted line. So now this is not, we cannot, how many times if I means take any data, okay, means any point, if this is, you can see this is the line, say if this is the line, the middle line, suppose if we, is drag will be there, no, say okay, let's suppose this is our data line. If I do duplicate this plot, okay, then look here, if this is a data plot, suppose we want to do the best fitted line, okay, if I draw like this one, like if we draw like this one, or maybe if I draw like this one, straight line, or maybe you can draw like this one, as always, maybe you can draw like this one, or maybe we can draw like this one. There will be some infinity point where it will be touched to the y point, and definitely the value will be, the y-intercept will be really huge. Okay, so from that approach, if this is the best fitted line, like the straight fitted line, the data point between this and this, the data point with this and this will be maximum. Maybe this and this value will be maximum. This and this will be maximum. Now our always target will be, the point will be, should be minimum. Okay, this is our main target. So you can see within the naked eye, you cannot tell that this is, we cannot do a best fitted line using the straight line itself, simply integration. Maybe I need to increase some other parameter. Okay, now I increased one parameter, I'll change it in a simple linear regression to some polynomial function. If I do one polynomial function, say suppose if this is a polynomial function, you will see this polynomial function will maximize maximum time cover the most data. Okay, so we can easily consider from where, from r square value. I'll tell you the different what is the r square, how we can calculate. This is the technique of calculating the accuracy. Okay, how the accuracy? Accuracy means here is nothing but the less distance from each data point to the line to get that more accuracy. Okay, so from that point we can even just forget about that math. Just from your eyes you can understand that this line definitely has some less distance value from each data points rather than the straight fitted line. So we can consider this is definitely one polynomial function will be, polynomial function definitely will be much better approach than our simple linear function, simple linear regression. Correct. This is, this is one approach. Now here comes the practical type. Practical work, you never knows when you will do the regression, when you will do the classification. Okay, you can only predict, you can only assume from your knowledge, from your hypothesis. Now this is one approach we did. Now one technique I can also do. Wonder, suppose if this is for polynomial regression, some kind of 93% accuracy we receive. Now I do one more approach. Say I create clusters. Say create one cluster here, or maybe some small clusters. Say one cluster here, another cluster here, and another cluster here, and maybe small cluster here. If we do some clustering algorithm, clear. You did some clustering algorithm, and sometimes I get some better accuracy, say 94.5%. Okay. In the end, our model should predict the best, not only this data, but also from that best of algorithm in the upcoming data. Okay. Now I did the cluster algorithm and I get the 90%. Okay. Now you will tell, okay, now I have the better accuracy. I have the better accuracy. Now I will consider this. Next step of our daily life of data scientists will do, let's test the data. Some new data point will come. Some new data point will come. Some data point may say those parts are there. Some data point are there. Some data point are there. Some data point are there. Okay, some data point also here also. Some data point are here also. Okay, some data point are here also. Some data point are here also. Now, the next time our polynomial regression will try to do the same things. It try to do the best, because the best fitted line also this model is also there. Now we try to predict the accuracy. Now for that data point, if we do that polynomial regression, so this data point you can consider the data is much larger value, or maybe say when we will do the clustering part, that time I will give you the basic concept. Okay, for now just listen. Maybe we'll try to find this distance for a polynomial one, then this data will be huge. Okay, some data will be huge, and some kind of I get that accuracy of say 67%. Okay, for this data. And for the clustering, what I will try to find, maybe for this point I will try to find from that cluster, and for this data point I never try to find from that cluster. I will try to find from that cluster, because that data point are the give us the least value. Okay, this is one step, and there are tons of other steps that we will do as along to get the most accurate value. But for our basic idea, with the zero concept, we'll do like clustering by this, and we can get much better accuracy because the difference value is the less. So we'll get the much lesser accuracy, and suppose our accuracy will be say 77%. Okay, so I will now consider that our better polynomial regression. Okay, better I will write. For our polynomial regression, I will get this value. Some say this is one, say k-means cluster. Okay, k-means cluster. I get this value. So I will definitely approach this one, or maybe I will try to test or 3 and 2 more data sets. Okay, and I will definitely approach. Okay, the k-means cluster will definitely do the better job, and it will gives us a much better accuracy than our polynomial regression. Then you finalize your product. Okay, now k-means cluster will be the best vegan algorithm. Clear? This is a complete, if we have done how a complete real life work, this is how a complete real life, the data set you live in, you do all the work, you just go for this accuracy, which one gives the maximum accuracy. Definitely some kind of other techniques. Other technique means say your parameter tuning. Okay, some hyperparameter tuning, some hyper parameter tuning. Okay, some data pre-processing, some data pre-processing. Those techniques definitely comes into hand, that which things you need to improve. Maybe some kind of hyperparameter tuning will gives you the more desired value in other algorithm rather than these two. It definitely does, but this comes later. Our main target is getting that first, which one gives us the best figuring algorithm. Okay, and some other technique also there, like overfitting, underfitting. Those kind of techniques are also there, we need to consider. This is how the real life scenario work. So that's why we need to first visualize the data, and then we start work along. Clear, I guess, all of you. Yeah, do you have any question of it? Okay, so this is joint plot. Now this part is, we, as I told you, that we never do the joint plot, because in that pair plot automatically it will do those things like univariate bivariate analysis. Okay, it will try to figure all those frequency distribution. This one, there is, this part is called, wait, there is one plot is there. Okay, the next division I will do. This plot also have two types of, one is this overlapping onto a single line and another one is not overlapping. That's I will do. We'll try to do the univariate analysis. Here you will do that total fill with a tip value. Okay, the bivariate analysis. In the pair plot, we'll get all those univariate and the bivariate analysis within. Now we can just see and just do some kind of judgment based on it. Okay, then for the further analysis, say suppose this one is right skewed, this one is right skewed, we can do some basic EDF. Okay, as because this is one total bill and this is a tip, so definitely because as we get the right skewed data here, so definitely it should be in the right skew. So you can see that our approaches are kind of matching. Then next we will go for the further EDF. Next, we can change the data value. We did not intend to, can using the palette. This is one parameter, and this palette there are so many values are presented, just such way you will get, and you definitely have to, maybe there are two parametric variable are there, then from providing that hue we can just give that value, and by default it will take that gender wise, the male and female, maybe some other values are there, automatically it will take. Okay, Cbon will automatically take it, you don't have to do that much thing, let Cbon to do each and everything. You will do that. First we will see that basic data privacy. Now we can get from the gender basis, the male and female, how much data are there, how much male and how much female are there, and just see everything with our naked eyes. Okay. Now rug plot, we generally much didn't work on rug plot. Rug plot is nothing but just see the basic distribution or the basic distribution of a single data set. Therefore, in the single line, you can see the maximum value of yellow between 10 to 20. It should be maximum value with 10 to 20. Why? Because that when a distribution, you can see that maximum value will be comes in the frequency of that the bin of 10 and 20. So it definitely it should be came in the 10 and 20. So our approaches is right, our data point is right. Okay, so you can see that our unified analysis is right. Clear. Next, our key parameter is the basic probability distribution. You don't have to go through it for now because you have to learn the basic normal regression. Okay, then after finishing that status part, then I will came again and discussing these two. Okay. Just give me a minute. I am having a call. Hmm. So we will come again in that plot, this bear plot. First we'll clear those basic statistical part, then we'll come again. This is nothing but we do that basic probability density function, and this all those function based on this each data point are established, nothing else. Maybe some kind of conjugate value will be there. So some accumulated, you can see some accumulated bins are there. This is the maximum of the standard normal distribution curve where mean comes into 0. That's why the 0 value will be there, and less of the standard distribution. Okay. For now, just ignore the KDE plot. We'll discuss in another session after finishing those two things. Okay. Now we came back to what is the part 2. Oh, I ended the. Okay. Now let's discuss about categorical data. This is important because some kind of data point that we'll start plotting, like some box plot, violin plot, swarm plot, bound plot, clown plot. Okay, those are the important point of the data we'll be plotting. We imported the data. One good thing is the bar plot. Bar plot is nothing but we do the categorical feature and the counted value or maybe the frequency of that categorical data. So the you can see that from the data point maybe 20 22 amount of male and some 17 or 18 amount of female public are there. This from the data point where we based on this total bills that have from there how many of the total bills, how many people are male, how many people are female. That's it. Simple bar plot and simple count plot, nothing else. The simple here nothing. One thing is first here we did that mean of the total bill. Okay, now maybe we have to change that from that standard deviation of the total bill. So we change from that estimator is equal to numpy np dot standard deviation. Those are the parameters that are providing. So now we are be considering from that based on this, obviously because that male peoples are maximum, so definitely the distribution, the standard deviation, okay, the maximum deviation of that interdistribution should be maximum on the male side rather than the female side. Not should be, probability of getting that maximum distribution, maximum deviation of distribution on the male side will be bigger than the female side, and from that probabilistic point of view we get the desired result. Okay, so anyway, these things simple as we'll do the bar plot. Next, count plot is nothing but we'll for that counted frequency, the most number of pairs will be counted and plotted. Okay, you can see the maximum number of male are came into the like 160 amount, and the female came into some 80 or 90 in between 80 to 100 means 90 amount. Okay, simple. Those are nothing else. Next come is box plot. Box plot as last day we already discussed same things. Nothing but in that box plot where that box and whiskers where inside that box are nothing but interquartile from 25 to 75% of the data set will be presented, and that middle black line, you can see the middle black line has nothing but the median of the data, and within that whisker you will see the 100% of our data, and some other dot has nothing but the outliers. We simply ignore that outlier and we get the 99% of the data. Okay, automatically because we give that data into the rainbow, so it is situated. This is another way of getting that bivariate analysis. Okay, these things we will do in our EDA part. Okay, this is the box plot. If we change that orientation, we have to change the orientation either horizontal or vertical. This parameter you have to provide, and this value will be printed there. Okay, this is nothing but our box plots. Okay. Next is our violet plot. This is box. Okay. One more is if sometimes we have to do in parallel within that same basis. Say one is your for that database, we have to count some categorical data. Okay, the figures of the categorical data, yes and no. I just plot it there. So you can count that from Thursday. The total bill from a smoking perspective will be lesser than a non-smoking perspective because non-smoking perspective the IQI interquartile range are bigger. Okay, so this is the basic idea you can tell based on this visualization. Okay, next came into your violin plot. Violin plot the same thing. Here we do the interquartile range. Here we'll see the distribution. Means nothing but this plot is nothing but here, maybe this is one plot, and all those frequencies of the distribution is there, the maximum data will be there. Okay, and this is your maybe median line, or here in the violin plot we will consider the median line. Okay, if we plot based on this one, then this value will be look like this. Like if we turn and this down, then this is say one value. Okay, where in between there should be one bar in violin plot. In the midpoint there should be the median value. This is an interquartile range, and this is the basic data distribution. Okay, and this is the the dispersion of the data. So the gap will be maximum. The maximum gap means the most data accumulated here. The lesser gap means the less data accumulated here. This point. Okay, same thing. This is, you can see the middle, the white point is nothing but middle point data. You can see if we increase that, then in that inside region it is nothing but your interquartile range, the black one. You can see at that median point the most data are accumulated. Okay, and the less the dispersion of the data, the less standard deviation of it. Okay, this is violin plot. Box plot we will do is the box. Violin plot will start to show some say in your violin plot will see the distribution. Okay, some accumulation of the data, as simple as that. These things we'll do. This is for the one category. If we do some change the categorical, then there is some male and the female category. We have to provide based on this one parameter. This is called hue. In the previously, this is the same parameter. This is hue. Okay, from this hue, we'll change that categorical data, the two categorical data. Okay, if we want to merge this plot into the one single one, then we'll do like this. Okay, we can do like the split into true. So within that yes and no, the two categories will be merged together. Okay. This is we will do now. Yes, this is one to do. One is strip plot and the swarm plot. Strip plot, there one is we by automatically it will accumulate it within each other, but if we want to, we do not have to accumulate in each other. We can to, by default there is one parameter called jitter. Okay, jitter parameter is false, that's why it do. But if we true that value, so the accumulation of this entire data will not be happen, and it will just presented here. Okay, the strip plot, this male female same is exact same things, provide that hue, the male female gender wise value will be there. Okay, and swarm plot will get that, for that distribution we'll get that better accuracy where no accumulation will be there, the swarm plot, and it looks much better. Okay, same things, same data point, same data. And one more important is we can do the merge two or more visualization into one. Say from this is a data visualization of a scatter one, and we can start plotting some violin plots to get the distribution of it. So you can see in between when we first did that violin plot, so it will created this estimate, and inside it we'll plot the swarm plot rather than by default plotting of our interquartile range and the median. Okay. So there are much more of it. Just go and explore. You will see factor plot. You already know nothing but the most in the categorical variable. It will nothing but plotted that frequency of it. Okay, the thing is, you know. So for that we will in general plot the histogram rather than the factor plot. Okay. Now next thing is grids. This is not the main thing we do. In grid we nothing but just the subplot. We majorly did using the subplot, so we will not create that empty plot. But sometimes if we need to create an empty plot and automatically not that plot each graph, rather than we mention which figure we need to plot here. So we first created that pair grids, then we just this is for automatically plotting here the pair grids using that SNS pair grids, the date, because SNS will we'll let SNS to do take all those feature and let it do by itself. Okay, but if we want to mention it, then we will mention that first we need to plot that map diagram. One is the histogram, upper will be the scatter plot and the lower will be the KDE plot. So we can see one that histogram, upper this is histogram plot, upper will be the scatter plot. You can see this upper plot is the scatter and last is the control plot, the KDE plot. Okay, sometimes if you have to need that, then you can use it. Then we do the pair plot. Just let write the pair plot and let see what to do each and everything. Okay, you can change that color using the palette. You can change it, or same things you can do that a facet grid. Okay, it's not much necessary. Just simple create that facet grid and provide which. Sometimes you have to provide the scatter, then write that from create that grid. Rule one is create that empty plate. If you start drawing, what you will do, you will first take the drawing paper, create create that canvas, then you will start painting. Na? Same thing, we are creating that canvas and then plot it, which things you need to plot. You created that canvas and then plot it, which things you need to plot. Okay, simple. And let Seaborn to do all those automated stuff. If we need to auto some trans fusion between those parameters, then just let it do all those things. Okay, similarly this we can join that grid. Joint grid is nothing but the things we do is in the unifier and the bivariate analysis. Seaborn automatically did that, but if we do the like, oh, you have to create one joint grid, then you can plot that joint plot. Okay, and give the joint grid, then you can plot the joint plot. But Seaborn automatically did. Then previously we see when we plot that joint plot. Okay, so you did not have to do those things. Yeah, and last is the matrix plus. Yes, this plot is important. Why? Because here we try to do that heat map. Heat map is nothing but the correlation of the each value. For every single feature, we try to correlate. The maximum correlated value will remove. Why this one is deep in color? Because we will be check the total bill within the total bill. Okay. So what is the correlation? In that correlation, we'll try to check how two data points move in which direction correlatively. Okay, suppose this is our y and this is our x. If we plot the data, if the data will look like this, then we can tell you that it's a huge positive correlation, because within the same value of y, we can tell you the same value of with the same value of x, we can tell you the same value of y is increasing. Okay, one thing. This is a huge positive correlation. Similar things, if these things will be there, this is our data point, then you can see from this value of x, this value of y are decreasing. So that's with the huge increase of x, a lower value of y is increasing. Okay, the higher is a negative correlation. So this is the how two data point are moving each other. This is the correlation. This is the main point of our bivariate analysis. Okay, so because this is violet came, that's my point to talk. Why? Because I am plotting x versus x. What it will happen if suppose this is 1 2 3 4 5, this is 1 2 3 4 5. If x value is 1, then x value is 1, then definitely this value will be here. Same 2 3 4 5 6. So always the value will be hugely positively correlated, because I am comparing the data within itself. This is a wrong point, but this is how here it will do. That's why it's already created the positive, the maximum value of the correlation will be 1. So 1 is here. And when comparing the from the total wheel to tip, from the total wheel to some size, then the value will be less. You will see when this point the correlation value is greater than 0.5 or greater than 0.6, will generally ignore those feature and we will not train those feature in our model. Check the correlation value using that I already see you in the pandas dot correlation. So we get that value. You can see using the total bill and the tip, the value will be 0.675, the most correlated value, but within the size and the tip, the less correlated value. Okay. So all those heat maps, either you can see like this, or you can, so like you can give that annote means the values of the correlation. Okay, sometimes you can pivot that value and get, this is how the real life the data will work. From that pivot value, we can see the heat map, the distribution of the two data. Okay, this is majorly heat maps we will check. And cluster map in general we don't do. The last time we will did that, like from the frequency distribution, the maximum cluster point it will try to find out, like the based on these correlations. Okay, you can see these two are mostly correlated. Okay, so this will be clustered within together. Then these two are correlated, and these will cluster together. That's why. Okay, ignore this cluster map because these things I will be repeating when we will be do the clustering algorithm. Okay, these things. And last is regression plot. You already know that regression plot is nothing but plotting that LM. It's called that LM plot is nothing but created that linear regression, or maybe if we want to do that distribution of it, then we change that hue and we change it to the maximum of male and the female part. Okay, sometimes if you need to this dot, maybe this blue dot and the red dot, you will change that marker. You simply mention that your marker will be O and V. So you can see the marker will change and it will what is it? The scales of your marker you can change using the scatter KWS. So you get some value. Those values are written into documentation. Okay. And this is the same things, the same place is sometimes you have to create that empty one empty plot, empty canvas, and then plot it. Sometimes you have to do the multiple time, the single one, then you can do like that. Okay, just always you have to provide like which column you want to do, which rows you want to do, and give that value point. Like X is your value point, Y your value point, the row will be your gender, sex, and your column will be time. So the value will be put in here. Okay, and there is no end, you can do the as much as you want. And there one more advantage is it gives you the projection. Okay, some projection of your data point in future, some bigger the part, some infinity amount of data will be there, so you can do the projection. You can also change the size of that canvas. Okay, but it's not recommended. If you need, you can do, but you don't need to do all those this kind of uh, configuration. You can just simply let C1 to do all those things, like these things until this part you can do, and then let C1 to do all of those kind of things. Okay, this is not the end because C1 has provided a million types of visualization for reason. This is only the some 3D and 2D plot. So higher degree of animation also provided using the C1. For now, we do not have to go that much deeper. Just simple plotting of the basic analysis using that module, you will learn. Okay. There are some exercise you are there. Okay. Do not do anything. Just copy that part. Copy this when I send you, copy this module. Okay. Those things are there. Just remember you have to do. This is your code. Just do those codes. Okay, those codes here, and this should be your visualization. So that's why always copy this one, plot the data and compare if the data is coming or not. Okay, if you practice these things, this is more than enough for your C1 to learn. Clear? I will send all each and every single of this module. Okay, you don't have to panic much.